Hey, welcome to another episode of 5-Minute Computer Science. My name is Mr. K, and today we're going to be looking at the Central Processing Unit. So if you don't know what an accumulator is, a program counter, an MDR, an MAR, a current instruction register, if all of these sound alien to you, I don't know what they are, then you need to watch this video. So let's put 5 minutes on the clock, boom, and let's make this happen. Go!
Okay, let's have a quick look at this diagram here. You need to remember that the processor is made up of a control unit, ALU, and lots of these little registers. And over the next couple of minutes, we're going to be looking at each one of these in brief. So the first thing you need to bear in mind is that all processing is done within the CPU. That's it. The hard drive doesn't do the processing. In fact, data goes from the hard drive into RAM, and then from the RAM into the motherboard, and then to the CPU. So this is where it all happens. Data is fetched, but it always processes in the central processing unit. Now, this is part of a concept called the fetch execute cycle. The idea behind this is that data is fetched from memory or from the hard drive. It's then decoded and then it's executed. So once that execution has taken place, the cycle starts again. The next bit of code or the next instructions fetched, decoded and executed. So the control unit, it performs this process. It's responsible for collecting that data and then decoding and executing and working with all the other components. So here's one of the components it works with, the arithmetic logical unit. Now, as it's arithmetic, you'll understand that it carries out all the maths, and it does this using logic gates and or not an exclusive or a combination of these to do addition, subtraction, multiplication, division. And you'll see here in this little graphic, all the ALU wants to know is what data do I have and what do I do with it? Well, you'll see here there's operand 1 and operand 2 and the opcode. And the opcode is simply saying take the values of operand 1 and operand 2 and place them inside this variable or value called result. So in the graphic you'll notice operand 1 is 786, operand 2 is 102. The ALU simply says I'll have the both of them please, thank you. I'll add them up and here's the result. And that's it. That's all the ALU does. Now the current instruction register, this holds the current instruction that's being executed or decoded at that very point. So when data arrives, it just looks like this, zeros and ones. And the processor has to work out what part of it is the opcode and what part of it is the operand. Now the opcode in this instance, you'll notice here, the first 3 digits here is actually the instruction add. And the second part of it is the instruction, or not the instruction should I say, but the data 45. So add 45 is the total of all of this. And then depending on the width of your buses that you're using, you can get more data flowing into the CPU at any one time. But that's all an opcode is and operand is. Another concept you need to understand is the program counter. Now the program counter's job is simply to say, well, what data is currently being executed and what's next? What's the next bit of code that the PC or the CPU is going to need? So you'll notice here we've got a condition somewhere in any kind of language which say is stored in slot 124 in memory. Well, the condition might be an if, else, then statement. So the program counter needs to say, right, well, if the condition is met, then I need to fetch the next bit of code, and that bit of code might actually be somewhere else in memory, say in 776. However, if it's not the case, if the condition isn't met, then the next bit of code might be somewhere else, like in this bit here, RAM slot 256. So the data may not necessarily always be next to each other, and it's the program counter's job to ensure that each of those is dealt with properly. So we've got the memory address register and the memory buffer register. The real difference here is that the address register is basically used to carry the location for the next bit of code that needs to be fetched, and the data register is the actual bus that brings that back to the CPU. Okay, so let's have a look at this actually functioning. Well, we've got over here the program counter, and the program counter currently is looking at slot 202. So slot 202 data or the address is passed on to the MAR, and via the MAR and the address bus, the location with the in-RAM, which is 202, is then accessed. Now what the address bus does is it finds this bit of data, but it leaves it to the actual data bus to transfer whatever is in there via the data bus back into the MDR. So the MDR now has the value of whatever this is, and of course that'd be in binary, but for this particular illustration we're using words that you can follow. Then that data is actually copied and transferred between the MDR and CIR and executed. And once that's finished, the program counter then moves to the next instruction, in this case instruction 203, meaning go via the address bus to location 203 and find the next instruction. And that's it. That's how it works. So hopefully that's been a really easy to understand video. That's been your 5 minutes, and this is 5 minutes computer science. Thank you.